So when we use the products and electronics that we use every day, we consume a large amount of electricity. Much of that electricity right now comes from coal-fired power plants. These power plants have a long lifetime, something like 40 years. So even if we decided to make a transition into a more carbon neutral or solar or wind power, these power plants are likely to stick with us for quite some time. As such, an important challenge is what can we do to mitigate their potential with respect to global warming. One way we potentially do this would be to retrofit these plants in such a way that we could capture the CO2 that's being emitted. And rather than emitting that CO2 into the atmosphere, we would trap it and sequester it potentially underground. This comes with a significant energy cost. These separations are tremendously energy intensive. Right now, using existing technologies, they would probably use up to 40% of the power generated in that power plant. So what we do in my research group is develop new materials that have the potential to enable new and more efficient separations. The types of materials that we examine are known as metal organic frameworks, or MOFs. These MOFs act like giant crystalline sponges. So the idea is that a MOF can absorb one gas with selectivity for another. In the case of CO2 capture, what we would like to have is a MOF which selectively absorbs carbon dioxide but does not absorb nitrogen. By passing a gas stream with a mixture of CO2 and nitrogen, the MOF would absorb the CO2 but allow the nitrogen to go through unabated. The potential of MOFs is really in that their chemical diversity. There are literally millions of possible combinations of metal cations or organic linker groups that can be made. And as we vary the chemical composition, the properties of the MOFs, its absorption capacity and selectivity of one gas relative to another all change. So a potential use of computer simulations is then to take the millions of possible MOFs and to identify promising prospects by using computer simulations to find those MOFs that may have a particularly high selectivity and capacity for CO2 relative to nitrogen. The subsequent challenge is then to take those promising candidates, to synthesize them, and then to test each one individually to see if the predictions made by the computer simulations are validated by later experiments.